Hello, pre-calcers. Today we're going to be doing 10.5, the Binomial Theorem. This is a statistics topic that is covered in stats courses. I know, Olivia, you're going on to be stats next year, and some of you guys are going on to take this in college. I want to make sure that we are prepared, so we're going to cover this topic. We're going to skip 10.4. It is on proofs by induction. It is a good topic, but I think we can wait for now. I'm not saying we won't go back, but I feel like there's better topics for us to cover. Our objectives are to evaluate a binomial coefficient, to expand a binomial raised to a power, and define particular terms in a binomial expansion. Here we have the definition of a binomial coefficient for non-negative integers n and r, where n is greater than or equal to r. The binomial expression n above r is called binomial coefficient and is defined by n factorial over r factorial times n minus r factorial. So this is defining that coefficient of the binomial. Okay, so here are our first two examples. We can begin by writing down that formula again. N above r, n factorial over r factorial, n minus r factorial. Okay, so remember that n is the number on top. So that is going to be 6 here. So we have 6 factorial over r factorial, that's 3 factorial, times n minus r, 6 minus 3 factorial. So this gives me 6 factorial over 3 factorial times 3 factorial. I like to use the expanding in the higher number, so we have 6 times 5 times 4 times 3 factorial, so that way we get to the 3 factorial. And then I know I only have one 3 factorial to be able to cancel with, so I can expand on the other 3 factorial. So 3 times 2, and we know it's going to have a times 1, but I don't have to illustrate that. So the 3 factorials cancel, and we know that 3 times 2 is 6, and 6 will cancel with 6, so we're left with just the middle 2. 5 times 4, which is 20. So the binomial coefficient here would be 20. Our next one up is 6 above 0, so we have 6 factorial over 0 factorial times 6 minus 0 factorial. So you end up with 6 factorial over 0 factorial times 6 factorial. This is rather convenient. Our 6 factorials cancel. We know 1 over 0 factorial. 0 factorial is equivalent to 1, so we know our answer here has to be 1. Okay, we have 2 more like this. We still have that same formula. N above r, n factorial over r factorial, n minus r factorial. So n is 8 factorial over 2 factorial, or 8 minus 2 factorial. This gives me 8 factorial over 2 factorial. 8 minus 2 is 6 factorial. I expand on the higher number, so 6 times 7 times, that's wrong, 8 times 7 times 6 factorial gets me to the point where I have my next highest factorial, 6 factorial. And we know that 2 would be 2 times 1, which is just 2. So I can now cancel things in between the top and bottom that are equivalent. So 6 factorial over 6 factorial is equivalent to 1. 2 divides into 8 4 times, so I'm left with 4 times 7. 7, 14, 21, 28. So my answer here is going to be 28. Okay, our next one up, we have 3 above 3, so we have 3 factorial over 3 factorial, 3 minus 3 factorial, 3 factorial over 3 factorial times 0 factorial. Once again, you see that you have factorials, 3 factorial over 3 factorial, which is equivalent to 1. So you have 1 over 0 factorial. We know this is equivalent to 1, so my answer here is 1. Okay, here's the try it yourself. So we're still using that same n above r, n factorial over r factorial, n minus r factorial. So we have 6 factorial over 2 factorial, 6 minus 2 factorial. This gives me 6 factorial over 2 factorial times 4 factorial. We're going to expand on the 6 factorial till we get to 4 factorial. So 6 times 5 times 4 factorial, all over 2 factorial, 2 times 1, so that's just 2, times 4 factorial. Our 4 factorials are equivalent to 1. 2 goes into 6 3 times. 3 times 5 is 15. So we see our coefficient is going to be 15. We're going to complete the next one. So we see that we have 3 factorial over 0 factorial, 3 minus 0 factorial. That's equivalent to 3 factorial over, we know 0 factorial is equivalent to 1. So 1 times 3 factorial, which is 3 factorial, and we know that is equivalent to 1 still. Let's go up to our next group. We have 9 factorial over 3 factorial, 9 minus 3 factorial. This is 9 factorial over 3 factorial, 6 factorial, which gives me 9. We want to expand it till we get to that 6 factorial. So 9 times 8 times 7 times 6 factorial. And then we have 6 factorial, but the 3 factorial is 3 times 2 factorial, or 3 times 2 times 6 factorial. The 6 over 6 is equivalent to 1. So 6 factorial over 6 factorial is equivalent to 1. And then here we see what we have in common. Well, we know that 3 divides into 9 3 times. And we know that 2 divides into 8 4 times. So we are left with 3 times 4 times 7. So 4 times 7 is 28. 28 times 3 is 84, if I'm correct. Double check my math. And then our last one again, 4 factorial over 4 factorial for 4 minus 4 factorial. 4 factorial over 4 factorial, 0 factorial. We know this is equivalent to 1. 4 factorial over 4 factorial is equivalent to 1, so we know that this is 1. I think this is as far as we need to go for today, so I will break this into a couple lessons. So make sure you try your homework.